ZombY.
Requiem, actual strike team is on the ground.
You have your orders, strike team. Investigate the site. Contain the threat.
Let's get to it then. This place is the cause of the outbreaks we're encountering. Better get inside and solve this case.
My team can handle it, Dr. Gray. They'll explore the site and find the entrance.
And I get to the guap real fast. I can get it. Let's go. Yeah, where do I get it? Why doesn't Steam have COD?
Five times.
Yeah, I guess so. I'm gonna uninstall the beta.
It's like I cannot miss today.
Well, some games are on Steam, right? Let me get this going. Oh my! Hold on, let me get my dad and payments.
Bring it on, Scheißekopfer. Now I'm getting warmed up. Brain. Zombie eliminated.
Nothing in the report about this place being haunted, is there? I hope not. These creatures, they're unlike anything we've ever seen before. What in God's name were the Nazis doing here? What was Project End Station?
What I want to know is why all that group so interested. Whatever they did here caused the other breaches we've encountered. Why would they resurrect a fucking Nazi experiment? Let's get the power on.
One might have felt on mine. I bought it though. Why is it not? Already on this product, so how do I download it? The rest of my downloads in Blizzard.
Energy stabilization required. Energy stabilization at 100%. Stabilization restored. Anomaly generated.
Doctor, do you know what this is?
Why is it
What
not
exactly am I looking at?
I don't know. It's similar to breaches we've identified in other outbreak zones, but it's more vibrant, more beautiful.
We're taking this shotgun.
Straight in, it's gone.
Are you there? Can you hear me?
I don't know if there's enough space on the
I got signal lock on. We're back in business. What happened? Satellite malfunction?
If I read this right, I think our team just went through the portal. Well, that's a first.
Oh, I have lots of. I have 127 gigs of free space. What's on my SSD? I'm gonna have to figure out how to make my download speed not like terrible. I think it's my like antivirus firewall slows it down. I don't know how to do it.
I will cut you all down. Frag peg. Yet another weapon for my kit.
Oh.
Undead threat cleared.
Now.
Right here, okay?
Also, you made it even more pissed off.
Yeah. I had to restart because my
Multiple hostiles. Not bad.
What?
Raptor 1 is nearby, strike team. Exfil window is short, so take it now if you're ready.
Yeah. I don't know. It doesn't tell me percent. It's like 10% or something. I'm trying to get it to. I'm trying to get the download speed up. Well, it's doing 11 megabytes a second, and my Wi-Fi can do 90. What's it?
Hey guys, it's Science Made Easier, and today I am going to show you how to find the wavelength or frequency when given the other. So let's start by looking at this triangle equation and defining the variables real quick. So c is your speed of light. This is a constant. It will never change. It will always be 3.0 times 10 to the 8th. V is your frequency, which is represented in hertz or seconds to the minus 1. Lambda is your wavelength, and it can either be in meters or nanometers. It is usually in nanometers though. So using this equation, you can substitute whatever you're given in that problem and find whatever you're not given. So let's try it in a problem. So let's say you have this problem. Light with a frequency of 7.26 times 10 to the 14th hertz lies in the violet region of the visible spectrum. What is the wavelength of this frequency of light? So we're looking for wavelength. So let's go back and look at the equation real quick. So if we're looking for lambda, which is wavelength, we have c over v. So we're going to divide the speed of light by our frequency. So let's go back to this problem real quick. So since we know what we're doing now, let's actually do it. So we're going to divide the speed of light by our frequency that we were given. So the speed of light is 3.0 times 10 to the 8th. And we're going to divide that by our frequency, 7.26 times 10 to the 14th. And that leaves us with 4.13 times 10 to the negative 7th. So since I said that nanometers is what it's usually in, we're going to convert from meters to nanometers. So all we have to do to convert from meters to nanometers is multiply by the conversion factor. So 4.13 times 10 to the negative 7th times the conversion factor, which is 10 to the 9th nanometers over 1 meter, which will give you 413 nanometers. So let's try another problem. So say you have this problem. Calculate the wavelength of radiation with a frequency of 5.00 times 10 to the 14th seconds to the minus 1. So seconds to the minus 1 is the same thing as hertz, so you can just kind of disregard that. We're finding wavelength once again, so it is the speed of light divided by your frequency. So let's do that. So 3 times 10 to the 8th divided by your frequency, 5.00 times 10 to the 14th. And that's going to leave you with 6.0 times 10 to the negative 7th meters. So we're going to convert to nanometers again, since that's what it's usually wanting anyway. So the same conversion factor. So 6.0 times 10 to the negative 7th times 10 to the 9th nanometers over 1 meter. And that's going to leave you with 600 nanometers. That's it for this video. If it helped, please show a little support for my channel by leaving a like. Thanks guys.
In this video, we're going to focus on a few problems that with these problems is minus negative 8 is the same as 8 plus 8, so that's 16. So the answer is 2 times 10 to the 6. So you take the top exponent, which is positive 8, and subtract it by the bottom one, which is negative 8. 8 minus negative 8 is the same as 8 plus 8, so that's 16.
So I think, I'm not for sure, but I think that Blizzard counts in megabits per second, which is 8 megabytes. I think I actually am getting good speed. Sure. Yeah, mine's tomorrow.
In this tutorial, we're going to focus on the different ways in which you can calculate the energy of a photon. So here's the first type of problem that you might see. So if you're given a frequency, how can we calculate the energy of a photon? You need to use this equation. Energy is equal to Planck's constant times the frequency. Now the value of Planck's constant is 6.626 times 10 to the negative 34 joules times seconds. And the frequency is 275 gigahertz, which we need to convert it to hertz. Now 1 gigahertz is a billion hertz. It's 10 to the 9. So therefore, it stands to reason that 275 gigahertz has to be 275 times that value, which is going to be 275 times 10 to the 9 hertz. So all you got to do is replace gigahertz with 10 to the 9. And that's a simple and quick conversion. So we got 275 times 10 to the 9. And hertz is the same as seconds to the minus 1, which is 1 over seconds. So the unit seconds will cancel, giving us the unit joules. Now let's multiply those two numbers. So 6.626 times 10 to the negative 34 times 275 times 10 to the 9. So the energy per photon is 1.82 times 10 to the minus 22 joules. So that's the energy for each single photon. So you could write joules per photon if you want. That's the answer. Now let's move on to number 2. That's the answer. Now let's move on to number 2. How can we calculate the single photon? So you could write joules per photon if you want. That's the answer.
What? Yeah.
Now let's move on to number 2. That's the answer. Now let's photon if you want. That's the answer.
Yeah.
Now let's move on to number 2. How can we calculate the energy of a photon
There's
if
also
we're
only
given
like
the
6
wavelength in
questions,
nanometers?
and I don't think it's gonna be that hard. Like as long as you
Now
just
there's
like
two equations that we
make
need to
sure you're
use.
careful and like yeah, as long as you're just careful and like make sure you're doing it right, then you're probably fine. I just reviewed like one problem. I think I'm fine. I'll do some more tonight, but
This one,
well, yeah,
Planck's
but like
constant times the
after, I
frequency,
think
and the
I'm
fact that
gonna go work out right now probably and just get it done that way. When I come back, maybe it'll be done. I doubt it, but I have IP. Alright, well, I'm gonna go have to work on Noah J. Just like he died in a stupid way, so he put the technical difficulty screen up. I shall be back. It's at like 25.
At the speed of light is equal to the wavelength times the frequency.
Maybe 25, I don't know.
Now I'm going to solve for the frequency in this equation. So the speed of light divided by the wavelength is equal to
how do you
frequency.
calculate?
You just got to divide both sides by lambda. And so now what I'm going to do is I'm going to replace the frequency with the speed of light divided by the wavelength.
How big was it? 80 gigs?
So the energy of a photon is Planck's constant times the speed of light divided by the wavelength. So this is the equation that you want to use if you wish to calculate the energy of a photon.
I don't know exactly how many gigs it is.
Photon given the wavelength of that photon. So it's going to be 6.626 times 10 to the negative 34 joules times seconds multiplied by 3 times 10 to the 8, that's the speed of light, with the units meters per second. The wavelength is 500 nanometers. Now a nanometer is 10 to the minus 9 meters. So 500 nanometers is 500 times 10 to the minus 9 meters. So we can see that the unit seconds will cancel. And the unit minutes, not minutes, but meters will cancel. So that leaves us with joules. So let's go ahead and type this in. So you should get 3.98 times 10 to the minus 19 joules per photon. And so that's the end of this problem. Now what about number 3? What is the energy of 5 moles of photons with a wavelength of 240 nanometers? Now in the last example, we were given the wavelength in nanometers, and we were able to calculate the energy of a single photon. Now we have to do the same thing but with a large number of. In this tutorial, we're going to focus on the different ways in which you can calculate the energy of a photon. So here's the first type of problem that you might see. So if you're given a frequency, how can we calculate the energy of a photon? You need to use this equation. Energy is equal to Planck's constant.
How do you calculate frequency if all you're given is the energy of a particular photon? Well, the answer is take your energy and divide it by Planck's constant. This is a rearrangement of the formula that we used to convert frequency to energy. We just divided by h instead of multiplying the frequency by h. What is the frequency of a photon that has that particular energy? Well, the frequency is the energy divided by Planck's constant. The energy is 3.8 times 10 to the negative 19 joules. Planck's constant is 6.626 times 10 to the minus 34 joules seconds. And when you do that on your calculator, you get 3.8 times 10 to the power of negative 19 divided by 6.626 times 10 to the power of negative 34. I get 5.73 times 10 to the power of 14. My units, well, joules cancel out on the top. Top and bottom, I'm left with seconds on the bottom. Oh, that's seconds to the minus 1. That's the proper unit for frequency. If you'd prefer, you can also say it's in hertz, because hertz and seconds to the minus 1 are the same. But it's that easy to calculate from energy to a frequency. Just divide by Planck's constant.
स्टूडेंट्स ये एनसीईआरटी प्रॉब्लम पेज नंबर 47 पे प्रॉब्लम नंबर 2.14 है, ठीक है। स्टेटमेंट में क्या कह रहे हैं, कैलकुलेट द मास ऑफ ए फोटोन विद वेवलेंथ 3.6 ऑंगस्ट्रॉम, ठीक है, कि आपको जो है मास ऑफ ए फोटोन फाइंड आउट करना है जिसकी वेवलेंथ कितनी है, 3.6 ऑंगस्ट्रॉम दी हुई है, ठीक है। अब मैक्सिमम बच्चों को प्रॉब्लम क्या आती है कि इसमें अगर हम डी ब्रॉगली रिलेशन भी लगाएं, ठीक है, तो डी ब्रॉगली रिलेशन के लिए भी हमारे पास वेलोसिटी गिवन होनी जरूरी है, क्योंकि डी ब्रॉगली रिलेशन क्या है, दैट इज लैम्डा इक्वल टू एच अपॉन एम वी, ठीक है, कि हमें मास फाइंड आउट करना है। तो आई विल मेक माई फॉर्मूला लाइक दिस, m इक्वल टू मास जो है इस साइड चला जाएगा, लैम्डा की वैल्यू नीचे आ जाएगी, सो h अपॉन क्या हो जाएगा, लैम्डा इंटू वी, ठीक है। h ऑब्वियस सी बात है, h जो है उसकी वैल्यू कितनी होती है, प्लैंक्स कांस्टेंट 6.626 इंटू 10 रेज टू पावर माइनस 34 जूल सेकेंड होती है, ठीक है। और यू कैन ऑल्सो राइट, क्योंकि मास की फॉर्म में बात कर रहे हैं तो डेफिनेटली हमें ये सब कुछ केजी में चाहिए, तो 6.626 इंटू 10 रेज टू पावर माइनस 34, 1 जूल किसके इक्विवेलेंट आता है, केजी मीटर स्क्वायर सेकंड इनवर्स स्क्वायर के इक्विवेलेंट आता है। तो ऑब्वियस सी बात है, साथ में हम जो इसका प्लैंक्स कांस्टेंट का सेकंड है वो मल्टीप्लाई कर देंगे, ठीक है। तो ये इसके साथ कैंसिल हो जाएगा, सो योर आंसर विल बी, अगर मैं इन सभी वैल्यू को देखती हूँ तो इट इज 6.626 इंटू 10 रेज टू पावर माइनस 34 केजी मीटर स्क्वायर सेकंड इनवर्स, ठीक है। ये हमारे पास प्लैंक्स कांस्टेंट की वैल्यू आ गई इन टर्म्स ऑफ केजी। अब लैम्डा की वैल्यू गिवन है, लैम्डा कितना गिवन है, लैम्डा इक्वल टू 3, तो डेफिनेटली प्रॉब्लम आएगी, 10 मीटर के इक्विवेलेंट आता है, ठीक है। तो ये वैल्यू आप यहाँ पे पुट कर सकते हो, तो ये क्या हो गया, 3.6 इंटू 10 रेज टू पावर माइनस 10 मीटर हो जाएगा, ठीक है। तो जब आपने ये वैल्यू यहाँ पे पुट की तो वेलोसिटी गिवन नहीं करना है, ठीक है, तो डिस्क्रीट फोटोन कहते हैं, ठीक है। तो ऑब्वियसली यहाँ पे हम लाइट की वेलोसिटी जो है वो फोटोन की वेलोसिटी कह सकते हैं 3 इंटू 10 रेज टू पावर 8 मीटर पर सेकेंड, मतलब वेलोसिटी ऑफ फोटोन जो है वो भी हमने फाइंड आउट कर ली। तो अब आप वैल्यूज पुट कर दो, क्या जाएंगी, m इंटू 10 रेज टू पावर माइनस 30 डिवाइडेड बाय लेमडा की वैल्यू डेफिनेटली आपने निकाल ली है 3.6 इंटू 10 रेज टू पावर माइनस 10 मीटर, ठीक है। वेलोसिटी भी आपके पास आ गई है 3 इंटू 10 रेज टू पावर 8 मीटर पर सेकेंड। यहां पे भी सेकंड इनवर्स है, यहां पे भी सेकंड इनवर्स है, तो ये सेकंड इनवर्स डेफिनेटली न्यूमरेटर में जाके सेकंड हो जाएगा और ये सेकंड इनवर्स डिनोमिनेटर में आके सेकंड हो जाएगा। तो ये आपस में कैंसिल हो सकते हैं, मीटर इसके साथ कैंसिल हो गया, 1 मीटर इस केजी 4 को 6 पॉइंट या तो यू गेट द आंसर 10.8 इंटू 10 रेज टू पावर माइनस 10 प्लस 8, तो माइनस 2 हो गया, ठीक है। यहाँ पे प्लैंक्स कांस्टेंट 10 रेज टू पावर माइनस 34 आ रहा है, ठीक है। इन केजी हमारे पास इसके यूनिट आ गए। ये -2 जो है यहाँ पे माइनस का है, ठीक है, तो न्यूमरेटर में जाके प्लस का हो जाएगा। सो 34 - 2
आउटलेट पर होगा, अब आपके सारे फिजिक्स
हमारे पास कैलकुलेट द एंगस्ट्रॉम कैलकुलेट करने हैं। एच जो है वो है प्लैंक्स कांस्टेंट, ठीक है। एम हमें कैलकुलेट कर, राइट। एच प्लैंक्स कांस्टेंट की वैल्यू फिक्स होती है, हमें पता है 6.62 इंटू 10⁻⁴ जूल सेकेंड। वेवलेंथ ऑफ लाइट, वेलोसिटी ऑफ फोटोन फिक्स होती है 3 इंटू 10⁸ मीटर। फोटोन फिक्स होती है 3 इंटू 10⁻⁻10। वेलोसिटी ऑफ लाइट, वेलोसिटी ऑफ फोटोन फिक्स होती है 3 इंटू 10⁸ मीटर पर सेकेंड। जब हम इसको सोल्व करेंगे तो हमारे पास आंसर आता है 6.135 इंटू 10⁻⁻20।
Question: how much energy is released when an electron drops from n equals 4 down to n equals 2 in hydrogen? Well, here's a hydrogen atom. If you give it a up, it's got a case of 2. We're talking 74 times 10 to the power of 7. H is the Planck's constant. H has a value of 6.626 times 10 to the minus 34. The units of that are joules seconds. It's in meters per second. And finally, we need these shell numbers. This is the shell you start in, and 1 over 2 squared. What you'll notice is that these are all these units just cancel each other out, and it's all numbers right here. Check it out. The answer let me hold this so you can see what I'm typing. 4 times 34, but that's negative power of 8. Out of the atom to your eyes, and the photons going pew out of the energy. Only there because pop quick of light. A photon, or which implies that when an electron jumps from n equals 4 down to n equals 2, it